Hi guys, this is Debbie and this is LM Squares, and today we'll be continuing our lesson on the methods of differentiation. Okay, so we talked about the general method, but today we'll be talking about the first principle method. So what is the principle, or what is the idea of the first principle method? Okay, so the principle or the idea of the first principle method is, listen attentively, add change in y to y and add change in x to x. We are having a change in y and we are having a change in x, so you will be adding these to both x and y. Okay, so let's take a look at the general method. Okay, when we're having y equals x, y equals x, let's differentiate this. The y over the x, I hope we can still remember, the y over the x equals, the power here is 1 times x raised to power 1 minus 1. Okay, so we'll be having 1 times x raised to power 0, 1 times x raised to power 0, which is giving me 1 times 1, finally giving me my answer 1. Okay, so let's continue. Let's see how we can use first principle method to differentiate. Okay, the example I have here first, let's take a look at this same example. Y equals to x, y equals x. I told us that we are adding the change in y to y and we are adding the change in x to x. Y plus change in y equals x plus change in x. Y plus change in y equals x plus change in x. Okay, so let me get this y out of here. I'll be having change in y equals x plus change in x minus y. I hope you know how this minus got to be. Okay, y is leaving this place, or I'm moving this y and it's coming over to this place, becoming negative. Okay, so but let's take note of this. Y equals x, that means our y is x, so the change in y equals x plus change in x minus x. I am substituting. Don't forget I said our y is x, so the y here is x, so I am substituting. Okay, now so I'm having x cancelling this minus x, it's giving me 0. X cancelling this minus x, so I'm having change in y equals change in x. Change in y equals change in x. Okay, so let's divide through by change in x. I'm having change in y over change in x equals change in x over change in x over change in x. So let me cancel this. This is cancelling this, equals 1. So I'm having change in y over change in x giving me 1. You see that it is similar to how we solved in the general method earlier. Okay, I'm having a second example here. I'm having y equals x raised to power 2. Okay, let's use the general method. Okay, I'll be having the y over the x equals 2x. How did I get my 2x? I hope you know. Okay, 2 times x raised to power 2 minus 1, that's 2x raised to power 1. That's giving me 2x. Okay, so now let's introduce the concept, or let's make use of the concept of the first principle method. Okay, add to y the change in y. I hope you get it. Add change in y to y and add change in x to x. Okay, so we have y equals to x raised to power 2, y equals to x raised to power 2. So adding the change in y to y, now I'll be having y plus change in y. I hope we're following. Y plus change in y equals x plus change in x plus change in x. Okay, don't forget I'm having a square up here. So I'm going to square x plus change in x. I'm going to square this because this x, or our x, was squared from the question. Okay, so I'm squaring it up here. Okay, so let's continue. How do we continue from here? Let us expand. X plus change in x raised to power 2. Let us expand this. Okay, so expanding this, let's introduce the binomial expansion. Okay, so I'm having x plus change in x raised to power 2, that's x plus change in x into two brackets. I hope we get this. Yeah, so x plus change in x into x plus change in x plus change in x. Okay, so let us expand. So I'll be having x into x plus change in x plus change in x into x plus change in x plus change in x. Okay, so let's continue from here. X times x is giving me x raised to power 2 plus, now x times change in x is simply giving me x change in x. Yeah, x change in x, not change in x raised to power 2. Please take note of this. X change in x, just place it out the way it is. Okay, now plus change in x multiplied by x, that will be giving me x change in x still. I hope you get this. Yeah, plus the last one we're having change in x here, change in x, change in x, change in x. Okay, so that's 2 of change in x, that's change in x raised to power 2. I hope you are following me. Change in x raised to power 2. Okay, so I'm having x raised to power 2 plus, now take a good look at this, I'm having x change in x plus x change in x. We have 2 change in x, which is adding up, so I'll be having 2x change in x, 2x change in x. I hope I'm getting this. Yeah, plus change in x raised to the power of 2, raised to the power of 2. Okay, so my final answer now is x raised to power 2 plus 2x change in x plus change in x raised to the power of 2. Okay, so let's go back to where we stopped. Yeah, so I'm having y plus change in y equals x raised to power 2 plus 2x change in x plus change in x raised to the power of 2, raised to the power of 2. Okay, so now let's make change in y stand alone here. Let's make change in y stand alone here. So I'm having change in y equals x raised to power 2 plus 2x change in x plus change in x raised to power 2 minus y. I hope you remember the first example, minus y. I'm moving this y from here, so minus y. Now going back to the question given, our y equals x raised to power 2, right? Y equals x raised to power 2. So let's substitute. Okay, so change in y equals x raised to power 2 here, x raised to power 2 plus 2x change in x plus change in x raised to power 2 minus our y here is x raised to power 2, don't forget. So let me put that x raised to power 2 in place of y. Yeah, instead of this y here, let me put x raised to power 2. Now take a good look at this. X raised to power 2 minus x raised to power 2. Let's cancel. Let's just simply cancel. Okay, canceling this and canceling this. Yeah, so I'm left with change in y equals 2x change in x plus change in x raised to power 2, change in x raised to power 2. Okay, so now let's divide all through by the change in x. So I'm having change in y over change in x equals 2x change in x over change in x plus change in x raised to power 2 over change in x. Yeah, I divided all through by the change in x. Okay, so change in x here canceling the change in x here. Okay, change in x canceling change in x plus, mind you, we have 2 change in x here. There are 2 here, so okay, let's divide. Okay, dividing here, I'll be left with 1 change in x, 1 change in x. Okay, because we have 2 up here, so 1 is canceling the numerator. Yeah, the numerator is canceling the denominator, the change in x here. Okay, so I'm left with change in x. So finally I'm having change in y over change in x equals 2x plus change in x plus change in x. Okay, so we got this, and we are still having a change in x. And once you solve like this and you're having a change in x, just take the limit of change in x. Okay, it is very simple. Just take the limit of change in x, which is 0. The limit of change in x is 0. Okay, so I'm having 2x plus 0 plus 0. Okay, so now I'm having change in y over change in x equals 2x equals 2x. So you remember when we used the general method, we also solved and we got 2x. I hope you understand the first principle method. Okay, so if you've not subscribed to my channel, make sure you do so. Like, comment and share this video so that other people can learn too. Thank you.